Today's topic is communication satellite and functioning of a transponder in our satellite. So initially in the previous session I have told about the what is a microwave link and what are the main function of microwave link and what is a satellite and what are the advantages and disadvantages of satellite communication over the terrestrial radio communication and what are the main applications of satellite. Okay, all of these are going to be covered in the previous session. That means what is a microwave link means it is working as same as that of the coaxial cable or fiber optic cable but in a different manner. So what it does means it is used for point to point communication or point to point microwave transmission between the repeaters. That means it is going to be receiving the transmitter signals from the microwave transmitter and it is going to be amplifying the signals and then it is going to be retransmitted. So that is a use of microwave link. And what is a satellite means it is a microwave link repeater that will be revolving or rotating around the earth. It is receiving the signals from the transmitting earth station and it is going to be amplify these signals and down converted and it is going to be sent to the receiving earth stations. So when we are having the satellite, it is a physical object that is going to be revolving around the larger body. Okay, so that is the satellite. So we are having number of advantages or a number of applications of the satellite. Okay, so and we are also having the classification of satellites also. Why? Because based on number of parameters the satellites are division. That means based on signal processing it is going to be division into active satellites and passive satellites, and based on the height it is going to be division into geosynchronous satellites and non-synchronous satellites. And based on the purpose of the satellites, when we are having some purpose, based on that it is going to be division into communication satellite and observatory satellites. And based on the area of working it is going to be classified into DOMSAT and Intelsat. What is DOMSAT means it is used for domestic purpose and Intelsat is going to be used for international telecommunication satellite. Okay, like this we are having the classifications of satellites. Okay, so what are the advantages of satellite means we are having number of advantages. Why? Because the satellites are having is going to permitting the high quality and is having a high capacity transmission over long distance, and this satellites is broadcasting the signals over worldwide. That means we are having the coverage area is going to be very high when compared with a single transmitter or any repeater station. And the mobile communication can be easily established by the satellite communication, and the quality of the transmitted signal and the locations of sending and receiving stations are independent of the distance. That is not going to be having any dependence on the distance. Why? Because whenever we are having the communication systems, if we are going to be increasing the distance coverage area, we have to place number of repeaters based on having the difference of 500 kilometers. Okay, like that we are having some cautions to have that distance coverage. Okay, so in this we don't have that. Why? Because the satellite is nothing but an when it is going to be placed above the earth curvature, it can be used by any earth stations. Number of earth stations can be having the permission to access that particular communication. Okay, so that is nothing but an the sending and receiving stations are not dependent upon the distance, and the satellite cost is not going to be dependent of distance also. Why? Because I have already told that a single satellite can cover over worldwide, and the cost is going to be very independent of the distance between the transmitter and receiver, and the satellite communication is more superior for such reuse, and the navigation purpose it is mainly used, and it is very cheap way of sending the information also. Okay, it is very economical in point to point, at the same time point to multi-point, and multi-point to multi-point communication also. So all of this can be done within the satellite communication. So what are the drawbacks of satellite means? It is the repair of the satellite cannot be possible in this, and there is some time delay between the telephone conversations and data transmissions because of varying the propagation path. So these are the topics which are going to be covered in the previous session. Not only with that, I have covered with the azimuth angle, elevation angle, what is an apogee, what is a perigee. So like this I have covered all of this. And not only with that, we are covered with the uplink frequency and downlink frequency also. So in this session I am going to say about the what is a communication satellite, and it having some block diagram, and I am going to explain the each block of the communication satellite, and what are the applications of communication satellite, and what are the functions of transponders in satellites. That is nothing but how it will works, what is the main function of the transponders in our satellites. So the first topic is communication satellites. The name already indicates that it is a communication purpose. So whenever a satellite is going to be using, it is mainly used for communication between the devices. Okay, so we are having communication devices, that is mobile communication, all of the comes under the communication satellite. Okay, so this is an block diagram of the communication satellite. So when we are having this communication satellite, mainly which consisting of number of blocks, and what are the blocks involved in this is nothing but an power subsystem, that is the main subsystem of any communication device, and we are having communication subsystem, and the third one is TTC, that is telemetry tracking and control subsystem. Okay, that is the telemetric tracking and control subsystem. Okay, that is shortcutly we are going to be calling as TTC subsystem. Okay, and the next one is altitude control subsystem, and the next one is antenna subsystem, and we are having the propulsion subsystem also, Okay, so these are the main blocks which are having in our communication satellite. So the name already indicates number of things. Why? Because we are all well known about this communication subsystems or communication systems. Okay, so what is the use of power subsystem means? In this, the name indicates that it will provide a power to all of the blocks which are having in this session, that is in the communication satellite. Okay, so all of the communication satellites obtain their electrical power from solar cells. Why? Because we are having in this, that is solar panel. So you can see this. So what is the use of solar panel means? In the daytime it will be charging, and at night time it can be utilized. So how it can be having the control of this charging and discharging means, that can be possible with this block, that is power subsystem. Okay, so in this we are having the charger and batteries that can be operate the satellite during the eclipse periods, that is whenever the solar panel is going to be charged, that is having with this, that means the charging of the solar panel that can be stored in our batteries. Okay, so in the daytime how much is going to be charged, that can be charged with our batteries, and that batteries is going to be providing the power at night time. Okay, that is the main use of chargers and batteries. Okay, and what is the use of regulator means? We are well known that the regulator will be having the control or to limit them, what do I say, they will limit the voltages to all of the subsystems which are represented in our communication satellite. So that is the main use. Okay, that means it is going to be providing the DC power to all the subsystems, both DC to DC, and whenever it requires the converting of AC, For that we are having the DC to DC converter, at the same time DC to AC converters also. Okay, so that means it will convert that particular voltages, and it is mainly used for some of the systems it requires the AC power. So for that system it will convert into AC, and some of the systems it is going to be converted into DC. So all of this can be having the control under the power subsystem. And the next one is communication subsystem. Okay, the communication subsystem, which is nothing but a heart, it will be calling as an heart of the communication satellite. So what it does mean, which consisting of a transponder. Okay, so transponder, this receives the uplink frequency and it is going to be amplified. And in this, what is the use of this means, the transmitter is going to be transmitting the signals, the receiving signals is going to be from the antenna, it will be receiving some signals, and it is going to be given for the frequency translator, which will be translates that uplink frequency to the downlink frequency. Why? Because whenever we are having the satellite communication, for uplink frequency is the 6 gigahertz and the downlink frequency is 4 gigahertz. So whenever we are having this, how it can be translated means by the use of transponder, this frequency translator. Okay, that will be converting the frequency from 6 gigahertz to 4 gigahertz, and it is going to be amplified, and then again it is going to be used for transmission as downlink signals, and which it consisting of antenna subsystem for both reception and transmission part. So that means for the receiving of the signals from the earth station and for sending of some signals to the earth station, single antenna is going to be used, that is one antenna is going to be used. Okay, so that is the communication subsystem. And TTC, that is telemetry tracking control subsystem, which will be monitoring the on-board conditions such as temperature, battery voltages, and transmitting of the data back to the ground station. All of this analysis can be done within the TTC. That means whether it is having some temperature effects, or whether it is having some voltage differences, or whether it is having some problems across the battery voltages. That means all of the controlling of this blocks can be done within this telemetry tracking and control subsystem. Okay, that means whenever it is going to be transmitting the data, it is also seen with this telemetry tracking control system. Okay, like this it can be done. That is the button to analysis, to have a control of all of the blocks, it is the main control, we can say like this. Okay, and next one is altitude control subsystem, and this system is going to be providing them stabilization in orbit. That means whenever we are placing in one orbit, so which will sees it is having the stabilization, and it will senses the changes in orientations. If it is changing them some directions, which will be noted with this, and it is having some thrusters to perform the altitude adjustments. That means if it is having any problems in the orbit, that can be seen with this thrusters. Thrusters is nothing but then a control to have an adjustment in our altitude. Okay, that means whenever it is having some changes in the altitude, that can be done with this jet thrusters. So what is the use of this is the button, just like a rocket. So what is the use of rocket means, when we have a fire at the edge, it will be moving towards the area. Okay, some distance is going to be moving. So like this, the just thrusters is also going to be same function is going to be done just like a rocket. So it fires the jet thrusters to perform the altitude adjustments. Okay, so like this it can be done within the altitude control subsystem. And the next one is propulsion subsystem. It is usually apogee kick motor is used to put the satellite into the final orbit. So for the placing of the satellite, it can be using this, and it is operated by the on-board computers in response to the command control subsystem. That means whenever we are having some commands, or whenever receiving some signals from the satellite, that can be done with this propulsion subsystem. Okay, then that means it is going to be operated by on-board computer systems to have a responses or to receive some commands that can be done with this propulsion subsystem. And the next one is antenna subsystem. All satellites have one or more antennas to used for receiving signals from the ground station and transmitting the information back to Earth. So that is the main use. That is whenever we are having a antenna subsystem, we can have a single antenna or we can have a number of antennas. So all of this comes under the antenna subsystem. Okay, so you can see the communications antennas also. Why? Because whenever we are having the communication part, not only with the single communication, we are going to be having number of communications. So for that, for the each communication, we are having different antennas. So like this, we are having all of the blocks in our communication satellite. That means it is mainly consisting of power subsystem, communication subsystem, telemetry tracking control subsystem, and attitude control subsystem, propulsion subsystem, antenna subsystem. Okay, so the first one is power subsystem. That means all communication satellites obtain their electrical power from solar cells, which is placed on the satellite surface, and they will charge the batteries and operate the satellite during the ellipse period, that is during the day period, and which will be distributing the DC power to all the subsystems. Both DC to DC and DC to AC inverter are used to supply special voltages to some subsystems which are going to be present in our communication satellite. So that means the power system, which is having nothing but we are having three parts, it is charger and batteries and regulators, protection and conditioning circuit, and third one is DC to DC converter and DC to AC inverter. So what is the use of this? Means which will be using the charging of the solar energy, and that energy is going to be used by the batteries, that is it is going to be charged by our batteries which are placed on in the power subsystem, and that is going to be regulated, and it is having some conditioning of that, and it is providing the power to all of the subsystems which are present in our satellite, communication satellite. And whenever we require an conversion of this, we are having the converters also in our power subsystem. And the next one is communication subsystem. I have already told that it is the heart of the communication satellite, and which is consisting of transponder. That means they will receive the uplink signals, and it is going to be amplified, and it is frequency translated, and that translation signals again is used for the transmission as downlink signals. That means it is going to be given for the earth station, receiving earth stations. Okay, so it consisting of antenna subsystems for both reception and transmission. Next, the telemetry tracking and control system. The shortcutly we can calling as TTC subsystem. Okay, which is used to monitor the on-board conditions such as temperature and battery voltage, and which will transmitting this data back to the ground station for analysis. I have already told that the telemetry tracking control is mainly used for whenever we having some temperature changes, or whenever we are having some battery voltage changes, and whenever we require transmitting some signals towards the ground station. The analysis of these things are going to be done within the TTC, that is telemetry tracking and control subsystem. Okay, and the next one is attitude control subsystems, so which will be providing some stabilization of the satellite in our orbit, and it is going to be sensing the changes in the orientation, and if it is changes in the position of the antennas, it will correct them. Okay, it fires the jet thrusters to perform the altitude adjustment. I have already told that if any having some changes in our orbit, it will having some jet thrusters, just like rockets. Okay, it will fire the just thrusters to perform these adjustments. Okay, that can be done within the altitude control subsystems. Okay, it is clear. And next one is propulsion subsystem. It is mainly usually apogee kick motor is going to be used to put the satellite into the final orbit. So it is operated by the on-board computers in response to the command control subsystem. I have already told that to have an response, to be given some responses to the commands from the control systems, that can be controlled by having a computer system. So in this, to have that control, we are having a kick motor, apogee kick motor. So I have already told that what is a perigee and what is a apogee. So what is an apogee means whenever we are having the target from the usage of that satellite, okay, so whenever the target or whenever we are having the fastest path, that is the longest path, is going to be calling as apogee, and the shortest path is going to be calling as perigee. Okay, previous class I have told about the apogee and perigee. Clear? So what is an apogee means when the satellite in the elliptical orbit, the farthest path from the earth of that orbit is going to be calling as apogee. Okay, farthest is nothing but it is the longest path from the earth of that orbit is going to be calling as apogee. Okay, so what is the perigee means when the satellite is in the elliptical orbit, the lowest point from the earth of that orbit is going to be calling as perigee. Okay, so the earth, from the earth to satellite, the longest path is going to be calling as apogee, and the shortest path is going to be calling as perigee. Okay, so in this we are having a apogee kick motor to use to put the satellite into our final orbit, and it is going to be operated by the on-board computers in response to the command control subsystems. Okay, next, antenna subsystems. So all satellites have one or more antennas used for receiving signals from the ground stations and transmitting information back to the earth. So that means we are having number of antennas to control all of the signals, or that is nothing but whenever we are placing a communication satellite, the communication satellite can be used for number of ways. So the each purpose is going to be having a single antenna to control that signals. So like this we are having number of antennas to control that. Okay, so that is calling as antenna subsystem. Okay, and what are the applications of communication satellite? So the first one is telecommunication, and the second one is telemedicine, and the third one is tele-education, and the fourth one is mobile satellite services, and fifth one is radio networking, and the sixth one is village resource center, and next one is satellite aided search and reuse, and the last one is satellite navigation program. Okay, so like this we are having number of applications. Why? Because well known about this, nothing but we are having the net connections, we are having the networking, we are having some communications, wireless communications. Okay, we are having the television systems that are also going to be used with our satellites only. Why? Because it is having the broadband areas, it can covering the broad area. Okay, it is covering almost all of the cities and all of the countries, so that can be used easily. Okay, so like this we are having number of applications. So what is the function of transponder? So first of all, what is the transponder means? It is the combination of transmitter and receiver in our satellite. So both the combination of transmitter and receiver we are going to be calling as transponder. Trans is nothing but two. Okay, so transmits, which is passing something. Initially it is nothing but passing something. So whenever we are using the transponder in our satellite, it does two works, that is, which will be transmitting some signals and it is also receiving the signals. Both the combination in our satellite is going to be known as transponder. Okay, which will be acting as RF repeater also. They are calling as RF repeater, and initially whenever we are having the communication satellites, we are going to be using 12 or 24 or more than that it is going to be used. Minimally we are going to be using 12 transponders, and not only with that, we are nowadays we are using with them 24 transponders also for our communication satellites. Okay, that means the transmitter receiver combination in a satellite is known as transponder, and it can be acting as an RF repeater. And in our communication satellites we are using the 12 or 24 or more than that it can be used, transponders can be used. Initially, what is the function of transponders in our satellite means, which will be receiving the uplink signals from the transmitting earth stations, and it is going to be amplifying the received signal, and it can be translated them into the downlink frequency and amplify again, and the downlink signals are going to be transmitted to the receiving earth stations. Okay, when we are having the transponder in our satellite, first of all it will receive the uplink frequencies from the transmitting earth stations, and that is going to be amplified that, and it is having the translation into the downlink frequency, and once again it can be amplified, and that downlink signals are transmitted to the receiving earth stations. The transponders contains the filters also, which are not only provide channelization but also helps to eliminate interference also. Why? Because whenever we are transmitting number of signals from the earth stations, we are having the probability to get some interference also. So whenever having this problem, the transponder having some filtering options, and it is used for filtering nothing but an channelization also, but not only with that, it is going to be eliminating the interference problem also. Let us have an quiz. Okay, so which of the following amplifiers is used in the transmitter substation? Which of the following amplifiers is used in the transmitter substation? The first option is RF amplifiers, and the second option is buffer amplifiers, and the third option is Klystron amplifier, and the fourth option is operational amplifiers. So what is an answer? Please note this question. So, which of the following amplifiers is used in the transmitter substation? The options are, the first one is RF amplifier, the second one is buffer amplifiers, the third one is Klystron amplifiers, and the fourth one is operational amplifiers. So, which of the following is going to be used is nothing but an C, that is Klystron amplifiers. So the Klystron amplifiers are used in the transmitter substation. Okay. And next question. Which part of the transmitter subsystem modulates the baseband signal? Which part of the transmitter subsystem modulates the baseband signal? The first option is antenna, and second option is up converter, and the third option is power amplifier, and the fourth option is mixer. So which part of the transmitter subsystem modulates the baseband signal? Whether it is antenna, whether it is up converter, whether it is power amplifier or mixer. Please note this question. So, which part of the transmitter subsystem modulates the baseband signal? The first option is antenna, and the second option is up converter, and the third option is power amplifier, and the fourth option is mixer. So, what is the transmitter? What is the part of the transmitter subsystem which will be modulating the baseband signal? That is up converter. In our transmitter subsystem, the baseband signal can be modulated by our up converter. Okay, this is an answer. And next, in the RF tuning section, dash provides the final up conversion to the microwave frequency. In RF tuning section, dash provides the final up conversion to the microwave frequency. So, what is the which will provides the conversion to the microwave frequency ranges? So, the first one is fixed frequency local oscillator, and the next option is RF frequency synthesizer, and third option is quartz oscillator, and the fourth option is magnetic oscillator. So, what is then which will provide the conversion, final up conversion to our microwave frequency ranges? So, what is an answer? Please note this question. So, in RF tuning, what will provide the final up conversion to the microwave frequency ranges? Whether it is the fixed frequency local oscillator, or RF frequency synthesizer, or quartz oscillator, or magnetic oscillator. That means in our RF tuning section, what will provide the final up conversion to the microwave frequency ranges? Okay, so what is an answer? That is RF frequency synthesizer. That means in our RF tuning section, RF frequency synthesizer which will be providing the final up conversion to the microwave frequency ranges. So, this is an answer. So, when individual up converters are used to modulate a channel, what is going to be used to combine them into the final signal? When individual up converters are used to modulate a channel, what is going to be used to combine them into the final stage? So, the first option is microwave combiner, and the second option is multiplexer, and the third option is mixer, and the fourth option is amplifier. So, when we use an individual up converters are going to be used to modulate a channel, what is going to be used to combine them into the final signal? So, what is going to be the option? So, please note this question. So, when individual up converters are used to modulate a channel, what is going to be used to combine them into the final signal? The options are A1 is microwave combiner, and B is multiplexer, C is mixture, and the last one is amplifier. So, what is an answer? That is A, that is microwave combiner. So when individual up converters are used to modulate a channel, what is going to be used means to combining the final signals to have a final signals, that is microwave combiner. The next question is, what type of satellite TV service used to compress the data transmission to beam signals directly to every home? So what type of satellite TV service uses compressed data transmission to beam signals directly to every home? The first option is direct broadcast satellite. The second option is mobile satellite service, and the third option is broadcasting satellite service, and the last option is fixed satellite service. So when we are having the satellite TV services, so what type of satellite TV service is going to be used for compressing data transmission to beam signals directly to our every home? So what is an option? Please note this question. So what type of satellite TV services using the compressed data transmission to beam signals directly to every home? That is, the first option is directed broadcast satellite, and the second option is mobile satellite service, and the third option is broadcasting satellite service, and the last option is fixed satellite service. So what is an answer? So whenever we are having the satellite TV services which are going to be used for compressing data transmission to beam signals directly towards our every home, what type of satellite is going to be used? So what is an answer? That is A. We are going to be calling as direct broadcast satellite. Why? Because we are all well known about the direct to home services, so that can be having with the satellite of direct broadcast satellite. Okay, so that is an answer. So next question is, which frequency band does the direct broadcast satellite system use? I have already in this session, what is the previous question means, this is the previous question, that is what type of satellite TV services use the compressed data transmission to beam signals directly to every home means direct broadcast satellite. So for that satellites, so what the band is going to be used, what that is, which frequency band is going to be using? Okay, so the first option is C band, and the second option is X band, and the third option is KU band, and the fourth option is MF band. So this medium frequency band. Okay, so like this we are having number of bands in our micro frequency ranges. So what band is going to be using? So please note this question. So which frequency band does the direct broadcast satellite system is going to be using? The first option is C band, the second option is X band, the third option is Ku band, and the last one is MF band. So which band is going to be used for our direct broadcast satellite system? So what is an answer? That is C, that is Ku band. I have already said that whenever we are using the satellite communication, most probably we are using with the C band, Ku band and Ka band only within the satellite communication, not with other bands. So the MF is not a correct answer and the X is also going to be not a correct answer. But for our direct broadcast satellites, we are going to be using with the Ku band. Okay, this is an answer. So in this session, I have told about what is a communication satellite and what are the main blocks involved in the communication satellite. Okay, what are the functions of the transponders? I have told about this. Okay, and what are the applications of communication satellites? Okay, what are the main blocks which are going to be involved in the communication satellites? And I have told about what are the functions of transponders. Okay, so whenever we are having the communication satellites, we are having number of blocks. The first one is power subsystem, and the second one is communication subsystem, and the third one is antenna subsystem, and the fourth one is telemetry tracking and control subsystem, and the next one is altitude control subsystem, and the next one is propulsion subsystems. Okay, so in the power subsystem, we are having the chargers and batteries and regulators, at the same time converters. So whenever we are having the solar panel on the surface of the satellite, the daytime it is going to be charged, that is we are having some solar energy is going to be coming, and that solar energy which comes from the sun, that is going to be converted into a DC signals. So how it can be converting means the charging of the batteries can be done in the daytime, and we are having number of chargers, that is we are having number of batteries in our power subsystems. Okay, so in that the batteries are going to be charged in the daytime and it is going to be utilized at night time, and whenever it is going to be charged, it is going to be having some regulation is going to be done within this. Why? Because in order to provide the voltages or DC voltages or DC power to all of the subsystems, and that is going to be having not only with the DC, you are also having AC. Okay, like this it is going to be there. And in the communication subsystem, we are having the transponder, that means it will receiving the signals from the earth station and it is going to be amplifying and it is going to be retransmitted, and by using of the transmitter, that means transmitter and receiver combination in a satellite is going to be calling as transponder. And when we are having the antenna subsystem, we are having the one or more antennas which are going to be used for receiving signals from the ground station and the transmitting information back to earth. Okay, so what is a telemetry and tracking system means? It is nothing but monitoring the onboard conditions such as temperature, battery voltages, and transmitting of data back to the ground station, that can be seen with this telemetry tracking control. And propulsion system is nothing but it is used to have operated by an onboard computers in response to the command control subsystem. Okay, and what is the use of altitude control subsystem means? Which will be providing the stabilization in orbit and senses the changes in orientation. It can be having the jet thrusters to perform this all adjustments. Okay, this is the altitude control subsystems. Okay, this is about our communication subsystem. Okay, communication satellites. So in the communication satellites, we are having number of panels. So I have told in this session. So I have covered what is an communication satellite and what are the main blocks involved in the communication satellite, and I have explained each block, and I have told about the applications of communication satellites and functioning of our transponders in our satellites. So thank you for this session.